Hello everyone, let's talk about another medium problem on Leetcode today. Create binary tree from descriptions. In this problem, we are given a 2D array descriptions where description I is equal to parent I, child I, and isLeft I. Parent I indicates the parent of the child in the binary tree of the unique values. And isLeft I is 1, then that means the child is the left child of the parent. If isLeft I is 0, that means child is right child of the parent. So we have to construct the binary tree described by descriptions and return its root. The test cases will be generated such that the binary tree is valid. Now let's look at the examples. In example 1, we can see that first description is 20, 15, and 1. So that means 20 is the parent, 15 is the child, and it is the left child. Then similarly, we see 20, 17, and 0. So that means 17 is right child of 20. So we find it here. Then we can see that 50, 20, and 1. So that means 20 is left child of 50. So we see this here, right? Then we see 50, 80, and 0. So that means 80 is right child of 50. So we create the tree like this. And finally, we see that 80, 19, 1. So that means 19 is the left child of 80, right? So we can see it here. So this is how the whole tree is constructed. So now let's see how we can solve this problem. In each description, we are given two things. One is the parent-child relationship, like who is the parent and who is the child. And second is like whether the child is left child or the right child, right? So what we can do is from each description, we can create a pair of parent and child node. Let's start with the example, then it becomes clear. So in example 1, in description 0, we create the parent node for 20 and we can see that 15 is the left child of 20, right? So we create these two nodes and we create the relationship between them. And let's say we add them to array for now so that we can link this part of the binary tree to the rest of the binary tree based on the remaining descriptions. Now the next description is 20, 17, and 0. So again, we will create two nodes. That is 20 for the parent node, 17 for the child node, and try to link 17 as a right child. But we can see that we have already created 20. So why not just search it in the array and link 17 as a right child to it? But finding the element in the array takes O of n time, where n is the number of elements in the array. So to overcome this, which data structure we can use here, which can actually speed up our lookup? And the answer to this is hashmap, because hashmap takes O of 1 time to add the element and O of 1 time to also look up the element. So how about we add the value of the tree node as a key in the map and value as tree node itself. So whenever we have to find the value based on a description, we just look it up in the map that takes O of 1 time and then link the parent-child relationship based on it. And why this algorithm will work? Because if you look in the start, we can see that binary tree has unique values. So a hash map will have no collisions. Now let's see how we can actually apply the algorithm. So we start with description 0. We get relationship of 20 and 15. So we will create two tree nodes, 20 and 15, and add them to the map as well. So 20 as an integer value will link to 20 as a tree node, and 15 as an integer value will link to 15 as a tree node. Now we see next description, which is 20, 17, and 0. So 17 is the right child of 20. So we check if 20 or 17 exists in the tree. And we see that, okay, actually 20 exists in the tree. So we get the corresponding value, that is 20 as a tree node. So we create a new tree node 17 and link 20 to it, right? And add 17 also to the map. Now our map has 20, 15, and 17. Now the next description is 50, 20, and 0. Because we see that 50 is not yet in the map, so we create a new tree node 50. We see 20 is already there in the map, so we don't have to create 20, but we create 50 and link 20 as a left child of 50 and then add 50 also to the map. So now our hash map has 50, 20, 15, and 17. Now the next description is 50, 80, and 0. So we can see that 80 is the right child of 50 and 50 is already created, right? We can see it in the map. So what we will do is we will just create the right child, which is 80, and link it to the tree node with value 50 by getting the value from the map. And we also add 80 to the hash map. Now the last description is 80, 19, and 1. So we can see that 80 is already present in the map and 19 is a left child. So we will create tree node 19 and add it as a left child to 80 and also add it to the hash map, right? So far so good. So we have created the tree node, but in the end, we have to return root as the answer. So how will we figure out the root? For that, let's look at the example one descriptions again. So the root node should be the one which never occurs as a child to any other node, right? And we can see that only 50 is the node which is always present as a parent relationship. All the other nodes are present as a child relationship. Like for example, 20 is a parent here, but then here we can also see that 20 is a child of 50. So what we can do is we can create a set of children in the first pass, and in the second pass we can again go through all the descriptions and see which parent has never occurred as a child at all, and that parent is our answer, right? And we can create this children hash set while updating our hash map, and that saves us one loop, or we can also do it as a follow-up. So that is up to you. Now let's see how we can fill and use this children hash set. Now we go through the children in the description one by one. So when we go through the loop, we can see that in the first description, 15 is a child, right? So we will add 15 to the set of children because this cannot be root. Then similarly, 17 is added to the children for the description 1. Then for description 2, we can see that 20 is a child, right? So we add 20 also to children hash set. Similarly, we add 80 to the hash set. And finally, we add 19 as well, right? So when we again go through a description, we can see only 50 is a parent which is never added as a child at all. So that will be our answer. So for parent 50, we will actually get the corresponding tree node value from map and return as an answer. Now let's see how we will code it. So first we will create the map where key is value we find in the description and value is actually the tree node that we create so far when we are going through the description. Again, we are using the hash map implementation because adding and looking up the value takes O of one time. Then we will also create set of children and now start going through the descriptions. So our parent is description 0, our child is description 1, and our is left flag denoting whether child is left child or right child is description 2 equal to 1 or not, right? Now we will add parent and child nodes to the map if not present. If it's already present, then we will just link the parent and child node based on the current description. So we will use map.putIf absent for both parent and child node, which will add the value to map if any of them is not present in the map. Now if it's left, then we will link the left child, otherwise we will link the right child. So we will do map.get parent because we will get the corresponding tree node for that parent value, and left is equal to child, right? So how we will do it is again map.get child, else we will do the same thing for the right child, right? In this pass itself, we will add the children value to the set. Like we said, I think we can also create a separate for loop, but it's not needed here. So now we have to find the root value for the tree node. So how we will do is like we will just go through the descriptions again. And this time we will just care about the parent now. And if children doesn't contain parent, that means this is our answer. So we will just return map.get parent. Else, if we couldn't find it, we will just return null. So I hope this was clear to you. Let's now run this code. Awesome. Let's submit this code. Cool. In terms of time complexity, it is O of n, where n is the number of descriptions. So we can see that we are actually going through the description first time and then second time. So it's O of 2n, but asymptotically it's O of n. And in terms of space complexity, because we are using map and set of children, in the worst case, it will be O of n again. So I hope this was clear to you. If it was, please like and subscribe. Have a nice time. Thank you.